Right, this is the 6th revision video for C1. It's on crude oil. So we're starting now to look at the hydrocarbons part of the specification. This bit's primarily going to be alkanes, and the next bit we're going to start looking at alkenes. So crude oil is a mixture of compounds called hydrocarbons. If you are asked in the exam to specify what a hydrocarbon is, it is a compound that is made up of hydrogen and carbon only. Really important you put that only bit in, because other things will contain carbon and hydrogen and maybe oxygen, like a carbohydrate, and that is not a hydrocarbon. A hydrocarbon is hydrogen and carbon only. Most of those are alkanes. So they are saturated hydrocarbons, and I'll draw some examples out of those in a minute. Saturated just means they're full of hydrogen. There's no double bonds, there's nowhere we can fit any more hydrogen in. They're completely full already. And they have the general formula CnH2n plus 2. So if we had ethane, which is an alkane, ANE, so we can see here we've got C2. So if we look at the formula above, Cn, so if that's 2, it will be 2 times 2, which is 4, plus 2, which is 6. So C2H6, and that's ethane. And it's drawn like this. You start with the carbons in the middle, and then you surround it by the hydrogens. Carbon can form a maximum of 4 bonds. You should only have 4 lines ever coming off carbon. So here we can see 1, 2, 3, 4, 1, 2, 3, 4 coming off that carbon there. Okay, and those lines we've drawn are covalent bonds. Okay, so they are very, very strong bonds, and it's where the electrons are being shared between the carbon and the hydrogen. So the examples you need to be aware of are methane, ethane, propane and butane. So go down in this order in terms of increasing carbons. If you can remember a rhyme for MEPB in some sort of order, that might be quite helpful. So with methane it's 1 carbon, so it'll be C with all the H's around it. So that's how you would draw methane, and the formula is CH4. So 1 carbon, 4 hydrogens. Ethane is drawn above there. Propane, we now go to 3 carbons. So we add 4 lines onto each. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And we fill that in with hydrogen. So our no double bonds at all in the alkanes. And that is C, 1, 2, 3. H, 1, 2, 3, 4, 5, 6, 7, 8. And butane is 4 carbons. 1, 2, 3, 4. And again we go round and we cover that in hydrogen, and then for the formula we simply add up the amount of hydrogens and carbons we have drawn. So 1, 2, 3, 4, C4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, H10. You can check, because I know the general formula is CnH2n plus 2. So if it's C4, that would be 2 times 4, which is 8, plus 2, which is 10, and that's correct there on that one. So that's your methane, ethane, propane, butane. You may well have to draw those structures out, so it's something that's worth practicing. Okay, so we know that crude oil is full of a mixture of these hydrocarbons, which are primarily alkanes. Okay, but we need to separate that mixture of crude oil to get useful products out of it, because as crude oil itself is not particularly helpful, we want to separate those carbons out, and to do that we can use something called fractional distillation, and that separates crude oil into fractions, and each fraction contains a similar number of carbon atoms. So here these would be in different fractions, and it looks something like this. You'd have seen something like this on your revision guide before, or your textbooks. So we've got, it comes into the fractional distillating column, and you can see here it's really hot at the bottom, becomes cooler towards the top, and at the top then we try and vaporize or turn these into gases. Okay, so these have reached their boiling point, they've gone from a liquid into a gas, and they're now coming off at different points, so it separates based on its boiling point. Okay, so at the top we have the small molecules that turn into a gas at lower temperatures, so your gas, your petrol, naphtha, kerosene, and then towards the bottom you have the larger, longer chain molecules. So these would be ever such long chain molecules, and these have to be really warm to get them to separate off. Okay, and these have different properties. So the ones at the top with the small molecules have low boiling points, they're very volatile, they flow really easily, and they ignite easily. We know that the gas in the lab will easily set fire for your Bunsen burners, whereas down the bottom, that thick residue is going to be really quite hard to ignite. Okay, so these will have high boiling points down at the bottom, so you have to get them really, really hot to get them to go from a liquid to a gas. They're not very volatile at all. They do not flow easily. They're very sticky and very thick, and they do not ignite easily. So we wouldn't want to be using residue as a fuel because it doesn't catch fire very easily, okay? So linking into that then, in terms of a lot of these down here are fuel names, you need to know about the consequences of burning a fuel. Okay, so when a fuel is burned, that's called combustion, and you need to know that word. That's a proper scientific term to burning a fuel, and it releases certain things into the atmosphere which are negatives. Okay, key one then is sulfur dioxide and oxides of nitrogen, so nitrogen oxide. They cause acid rain, okay, which is really not very nice. Okay, and it falls down and it can damage to an extent some buildings, maybe made out of limestone, okay, or soft rock. It could damage trees or ponds, etc., in areas which was very polluted and releasing quite a lot of acid rain. The carbon dioxide that's released when a fuel is burnt, okay, causes global warming. So if you think about it logically, when we burn something, we burn it in oxygen, and we've got hydrocarbons containing carbon. So the carbon in the hydrocarbon reacts with oxygen in the air and produces carbon dioxide. We know carbon dioxide is one of the main contributors to global warming, okay, which causes climate change, etc. So make sure you know about that one. And finally, any solid particulates within the fuel will cause global dimming, okay? So again, that's different to global warming. So make sure you know and can clearly state the different things. Don't use the words incorrectly. Most of the sulphur, though, that's produced by fuels is removed either before or after burning. So it might be in catalytic converters and exhausts. It might be in chimneys of industry, etc., to try and remove that sulphur, or it could be prior to the fuel actually being burned. So we do try and remove that sulphur so we don't get acid rain being caused. And then the other fuel that's being developed is a biofuel, and that's produced by plants. Remember, bio is the study of living things, so biology is the study of living things, so bio links to living. So biofuels are fuels that were once living or from something living, and they're produced by plants, okay? So we can get a biofuel like ethanol, for example, and that's produced, which is great because it produces less of these pollutants. However, we need a huge amount of space to grow these biofuels. So that's a negative to the biofuel manufacturing, because we have to potentially destroy large areas of forest, for example, to grow the crop to then produce enough fuel for the cars that we need to run, okay? So that's crude oil, and they're the key bits from the specification you need to be aware of. Again, you need to go and practice these now with some exam questions and put it into context. So crude oil is made of hydrocarbons, which are compounds which contain only hydrogen and carbon. Most of it's alkanes in crude oil. They have this general formula. Drawn out the examples there for you, so you've got a reference point. We can separate those alkanes in fractional distillation. Small molecules at the top, large at the bottom. Know some properties of both. And then we've got the consequences with burning a fuel and what we get produced and how that can cause pollution in our atmosphere. Using the word pollution is not good enough. You need to talk about the actual specific bits, so acid rain, global warming, global dimming. Okay, so that's crude oil. That's the 6th revision video in C1.